Hi everybody, Sam from Developing Mathematical Thinking. In this video, we're going to take a look at one of the more complicated ideas when it comes to subtraction. This is something that shows up a lot in 4th and 5th grade, and it's regrouping across zeros. There's a lot of background knowledge before we get to this point, so if you haven't watched our other videos on addition and subtraction, take a look at those because they'll scaffold some of this learning and clarify some of the processes here. What we're going to look at is we're going to model and describe using structural language this particular problem here, 1003 subtract 324. Then we're going to connect that to this problem, which is essentially the same, just one digit is different. But before we even get to this point, and before I show you how to model this and talk about it structurally, one suggestion we would have when we're teaching something like this that's such a difficult technique, there's the temptation to often have kids practice multiple versions of this same exercise. So for example, an entire page of 20 problems that all include regrouping across zeros. There's nothing necessarily wrong with that in the big picture, but for teaching purposes, one strategy we really suggest using is a problem string where we ultimately have a target problem, these last two here that we're really trying to work on. But if you look at each of these problems in the string, you'll see that we're gradually making subtle changes each time that makes the problem increasingly more difficult. That actually will have kids be more successful at solving these more complicated ideas than simply practicing these over and over and over again. And so just to explain the problem string and the rationale behind this sequence, you can actually come up with many other versions. This is just one that we like. We start with one that doesn't have the regrouping. Then we have regrouping in the ones. Then we have regrouping in ones and tens. Then we introduce a zero that we're going to regroup across. Then we have the two zeros. And then we also have the two zeros, but just vary the largest place value that we're going to work with. So that's kind of a nice technique. That structure, if you like it, I would just practice that over and over to get kids to solve these problems. So now let's go to our target problems here. And I'm going to start with this one precisely because we want to visualize it. We want to model it. And this problem, the 9,000 is so much larger than the 3 units of 1. It's really hard to model that correctly. So we're going to use a slightly easier number set so we can still model it visually and then connect those procedures here. Okay, so let's start here. We have our 1,000. Then we have our 3 units of 1. They're close to scale, not exactly, because again, those relative sizes are pretty large. Okay, so let's start with our units of 1. And instead of saying we can't take 4 from 3, we're going to say, well, we only have 3 units of 1. We need to take away 4 units of 1. We need more ones. Now, traditionally, we would then move to the tens and decompose a unit of 10 into 10 units of 1. But we also don't have any units of 10 here. Okay, well, let's go to the hundreds to get tens. We don't have any units of 100 either. So we're going to go all the way to the 1,000. We're going to decompose or partition that into 10 units of 100. So I'm going to do that visually first. Now I'm going to do that symbolically. And there's a lot of different notations. I personally prefer this version to actually show the 10 units of 100 first. Eventually kids will get into the pattern of just putting the 9 there. I do think in early learning it's helpful to list that we actually have 10 units of 100. Now, you might notice I didn't really change anything, but it's still nice just to communicate exactly what we're doing. Now, I can use my hundreds to get 10 units of 10. So I'm going to decompose 1 unit of 100 into 10 units of 10, because my ultimate goal is to get 10 units of 1. Now that I have 10 units of 10, I can decompose one of them into 10 units of 10, and now I actually, or 10 units of 1, and now I actually have 13 units of 1. Then I can go through and I can complete the subtraction. So 13 subtract 4 would be 9 units of 1. I can model that. 9 tens subtract 2 tens would be 7 tens. I can do that. 900 subtract 3 would be 600s. And I decompose my thousands so I don't have any thousands left. So that ends up being the difference. A nice strategy sometimes with kids is also to have them draw a new place value model of the difference if you want. Not something they have to do all the time, but can be helpful when they're first learning. Now let's connect what we did here to this just slightly varied problem. Now I'm going to look at the ones. I need more ones. Want to look at tens to get 10 units of 1. I don't have any units of 10. Go to the hundreds. I don't have any units of 100, so we're going to start all the way over here and decompose one of the thousands into 10 units of 100. Then I'm going to decompose 10 units of 100, or one of those hundreds into 10 units of 10. Then I can decompose one of those into 10 units of 1, and now I have 13 units of 1, and I can complete the subtraction there. But again, just in summary, probably to attack these, instead of doing 10 or 12 of these problems, we would suggest building up with a string like this so kids can watch as the digits change and look for patterns in the computation. Hope that's helpful, and please watch the other addition subtraction videos. They'll help explain some of the background knowledge here.